Hi folks, in this video I'm going to introduce the concept of decision trees. So this is the simplest and the most successful and one of the most successful forms of machine learning, and it has pretty long history. It was developed back in 1970s. And the goal of decision tree model is to produce outcomes by guiding an output through multiple questions. So the basic idea is similar to questions game. I believe that you must have played this game when you were young ages, right? So maybe there might be a player who has to guess the answer, and to find out the answer, the player might ask a series of questions, and you may direct the player. You may give the hint to the player. So here's a really simple example of decision tree. So maybe you have a number x, and maybe this is the integer between 0 and 7, and your player may have asked 3 questions to identify the number in your head. So in the first chance, maybe the player asks, is your number greater than 4? And in the next level, the player may ask, is the number greater than 2 or 6? And after that, your player may ask the following questions so that they can identify the answer, something like this, right? So this is, very simply capture the basic idea of decision tree. So it is a function, numerical function that takes an input as a vector of attribute or feature values, and then returns a decision or output value. And in this method, you can use a variety of types of input data, such as categorical data, something like what color is it, which day is it, and you can also use numerical data as input, such as what is the value of x. And the output depends on the task. So for classification task, the final output can be a discrete classes or labels. It can be like red color, blue color, something like that. And for regression task, of course, the final output would be the numeric values. It can be like x of 7 or x of 7.6, something like that. So that's the basic idea of decision tree. And for programming, of course, you need to define the components of the decision trees. So this is the structure of the tree. You will have multiple decision nodes, and each decision node direct your input to different branches, something like this. So the node is split to multiple branches, something like this. And after going through multiple nodes, then your input will arrive at a certain leaf node. Okay. So and the leaf corresponds to the output. And the decision node will direct your input based on their test. So it can be yes or no question, or A or B question, something like that. And of course, you must train your decision tree model. So at the beginning, the model is simply a blank. So it actually cannot direct your input to the right output value, right? So there must be a way that you train your model such that your model gives you the correct, an accurate output value. Of course, the first step should be you make a tree-like structure in machine learning code, which direct the data into subsequent nodes based on their feature, but your model will not know how accurately direct your input to a correct output leaf node, right? So your model should learn from training data. So you will provide a large number of training data here. And then now the decision node should determine which feature, which aspect of the data should be used to direct the data into a right branch, or yeah. So the decision node should know how to bring your data into the next decision node. So for the decision tree model, classification and regression tree method, which is abbreviated as CART, is commonly used. So this method will generate several splitting questions, and if the feature handles a continuous variable, something like maybe numeric value can be the feature, maybe the temperature value can be the feature of your input. So depending on the value of your input, it will split, it will direct your input to a certain branch in the tree, right? So coming up with the feature and the splitting condition should be determined using this CART method. And sometimes the feature can be a categorical information, and then the splitting question should be, is your feature belong to a certain category? For example, is Tempe belong to the cities in Arizona? So depending on the answer, your input will be directed to different branches, right? And then there must be a measure of your training method. So computer should know, the program should know if the directing or splitting of your input is done correctly or not. So there are two famous measures which are called entropy or Gini index. So entropy is basically the measure of randomness based on the distribution of outputs. So it measures how randomly distributed your final output for many different inputs. So entropy zero means that all input. So maybe you can put many different inputs to your tree, and if all data are directed into the same output label, leaf node, it means that entropy is zero. But sometimes your decision tree may direct all the inputs into multiple different outputs. Sometimes maybe the same or very similar input can also be guided into different output, then you have maximum entropy. So the either zero entropy, maximum entropy are not good, depending on your task. So there must be some ideal value of entropy. And also you can measure what is the error, how often your tree incorrectly putting your input to the wrong, incorrectly putting your input to certain outputs, right? So by comparing the true answer for each input, you can measure the Gini index. So by measuring the entropy and the Gini index, your decision tree program will automatically update their classification splitting questions and which features they have to look at in each decision nodes. So after correcting and improving the decision nodes and the questions, then your tree will be well trained. And then so you can repeat this training learning process until a certain stopping condition is met. Okay, so and common stopping conditions are the maximum depth of the tree. So which means how many levels of decision nodes should be included in your decision tree model, and how many samples should go into your leaf node if you have a certain number of input data. So the minimum threshold of for the output data in each leaf node can be a stopping condition if you have a finite, predefined number of input data. So that was how you define a single decision tree and how you train each model. But commonly, people use ensemble learning method to get more accurate result. So again, decision tree is a statistical method to generate certain output. It's not, it doesn't guarantee it gives you exact answer or just accurate answer for any input. So to be safe, people use ensemble learning method. So basically you generate multiple models and then make each model to create their output, and then you collect them and take the majority or average as a final output. So the models you are going to make are likely to be different between each other because you're going to use different training data to train each model. And there are some randomness when you are training each model. So the features for each decision nodes and the questions for each level of decision node can be different between different decision models, right? And there are two major learning scenarios for in ensemble methodology. So one is parallel training method, which is also known as bagging method. So you have multiple models, something like this, and you train them at the same time using different training data. So maybe you have a big size, a big original data, something like this, but maybe you can sample different data from the big data, right? And then you assign each subset data to different models. And then using each subset training data, you train all the models. And finally, you're taking the output of each decision tree and then take an average or take the average of the outputs to get the final answer. So that's the bagging method to train the entire decision trees. And there's a subsequent training method, which is also known as boosting method. In this method, you're not training all the models at the same time, but you train each model one by one. So basically, you provide the original data to the first model, and then there might be like correct training result, correct output, and there might be incorrect result, right? And then so you label them as, okay, so these are the cases where your model, initial model, correctly predicted, correctly classified. And you can also label the incorrect cases that, okay, so our model, our decision tree was not well trained to predict or classify such cases, okay? And using these cases, so you actually assign some weights on the failed cases here. And then now you're trying to train your next model while focusing on those failed cases, right? But you will still have failed cases, and then you apply more weight, and then subsequently you train your decision tree until you have correct output after going through multiple decision tree models. So this is called a boosting method. But there is a very well-known method for decision trees. So it's called random forest algorithm, which basically means the ensemble of many decision trees. So you create multiple decision trees, and then you train them in parallel. So this is similar to the bagging method. So you split the training data for each tree, and then after training, you let them generate the output, and after you collecting all the outputs, you take the average, or you select the majority output, and then you take that as the final answer. So this is the basic concept of the random forest. And in the next video, we will look at the code, a Python code that was used to build a random forest model for the rough channel data. Okay, thanks for watching the video.